Hey there everybody, my name is Bradston and welcome to episode 2 of the Creating a Unity ML API multiplayer game here on my channel. I'm so excited to have you guys here. It's going to be a great episode. Today we'll be diving into the ML API framework that is the underpinning of the Unity multiplayer networking system. So we're going to get into the meat and potatoes of what really makes our multiplayer networking system work and how we can use it in the core concepts that we'll need to perform our best with our Unity multiplayer game. Just in case you're interested to know, ML API is an acronym and it actually stands for Mid-Level Application Programming Interface, and its whole goal is to allow developers to focus on game design, game development, and all the things that we love, and take our focus off of the low-level protocols and networking things that we would need to do to make a multiplayer game work. As I mentioned a little bit earlier, ML API was actually a community-driven effort by Unity developers and developers at large who really wanted to see a networking protocol or networking system that really worked well within Unity. Well, Unity saw the promise of this framework and said, hey, we want it to be a part of our ecosystem, and acquired it, and now Unity's full support is behind it, and so we have a lot to expect in the future of it getting better and even greater than it is at this moment. Now that we've gotten a good look at what ML API stands for and where it came from, it's time for us to jump into the core concepts of ML API and how we're going to be using it in our coming multiplayer game that we'll be creating. One thing I want to note is that this is not an exhaustive list of all of the core concepts or all of the functionalities. This is just the core. When I say the core, the meat and potatoes, things that we really want to know when we get ready to start making our multiplayer game. Just a quick note before we get started. As we go through this video, I'm going to have an assumption that you have a basic understanding of Unity 3D's engine and some of the core concepts like game objects and transforms and things like that. So as we get into things, I'm just not going to stop and talk about those things because I'm going to have the assumption that you know what they are. Alright, so let's go ahead and get started. So the first thing that we're going to talk about today is the network object component. I want to start with the network object component because as we make our multiplayer game, we're going to be using this a lot. And this is going to be something that is going to be the core underpinning of pretty much everything we do and how we make our multiplayer game. Think of the network object component as the main way that ML API tracks game objects in all of the different players' games while we're having a particular multiplayer game session. In particular, when a network object component is attached to or associated to a game object, it allows our networking system, the Unity networking system, to be able to replicate that particular game object in all different players' games. The network object component is so incredibly important because other functionalities of the ML API framework, such as network variables and network transforms, do not work without them being associated to them. We're going to be using the network object component quite a bit as we make our game project, so even if you don't understand some of the concepts of what a network object component is and what it does, you'll get very, very familiar with them as we continue to work in our game project. The next core concept we're going to cover is the network manager. The network manager works as its name suggests. It manages all things that are related to the network settings, registered scene names, network prefabs, and even our IP addresses. It's also what we'll be using to start and stop our clients, our hosts, and our server as we're making our game and starting gaming sessions. That is key functionality because without the ability to start a server, start a host, or start any type of client, we're not going to be able to allow our players to connect with each other and play with each other within our multiplayer game. If you're not super familiar with the ideas of host, client, and server and different concepts like that, that's absolutely okay. You're going to be learning a lot about that as we go through this series, but I really encourage you to check out one of my earlier videos from my previous series where we talked about creating our own multiplayer game server. You can check that out in the description below. I'll make sure I leave that link so you can check it out and learn a little bit more. But essentially, the network manager is the overseer of all network configuration information and is the way that we manage players connecting with each other. So it is a key thing when we're creating our multiplayer game. Now we're going to talk all about network transforms. If you're familiar with the idea of transforms in Unity game development in general, the network transforms are going to be very natural to you and are going to really be easy for you to understand. A network transform, when associated to a network object component, allows us to synchronize size, scale, and rotation across the network of any particular game object at any particular time. In practice, what this looks like is when a game object in one player's game changes position, changes rotation, or changes size, that change is reflected in all other players' games as it happens in real time. It's interesting because if you're anything like me and you play games on a regular, you kind of take this type of functionality for granted. This is actually a huge benefit for us as developers, because if we didn't have this functionality baked into the ML API framework, we ourselves would have to manage this throughout the network, and we have to store this data and try to pass it in different ways. But the ML API framework gives this to us for free with the network transform component. One thing I did want to note about the network transform is that they are synchronized from the server to the client. I'm not going to cover this in great detail in this particular video, but ML API is essentially a server authoritative system. That means that essentially at any given time, the server acts as a source of truth on what's happening in our game. What that really means is at any particular time, our network transform will always reflect what the server sees, not particularly what the client sees. Now, if that particular statement doesn't make a lot of sense to you or is not super clear, that's okay, because as we're developing our game, we're going to talk about this a little bit more, and it's going to make a lot more sense as we move forward. The next concept that we're going to briefly cover is called the network variable. In short, the network variable allows developers to synchronize state across the network. So imagine you're playing a multiplayer game that is a timer-based multiplayer game. So what's really important is that every player in the game has the same exact time on their timer as every other player who's playing the game. In that case, as developers, we could use a network variable that would be associated to our timer time that would synchronize the state of that time to all players on the network. As you could probably note, network variables are really important for making sure that all players have the same information at the same time. As we're building our project, we're going to be using network variables a ton, so we're going to learn a lot more about them and how they work. Now let's talk about what's called a network behavior. Similar to what I mentioned about network transforms, if you're familiar with the idea of mono behaviors, network behaviors will feel somewhat natural to you as we cover it. If you're not familiar with what a mono behavior is essentially the base class that all Unity functionality within scripts derives itself from. Similarly, a network behavior is the base class that all network functionality derives itself from within any particular script. Just a quick thing to note, a network behavior is actually an abstract class that derives itself from mono behavior. There is a ton to know about network behaviors, but I'm not going to cover much about it in this particular video. But as we continue to code and develop our game, we're going to learn a lot about network behaviors and how, when we're writing our scripts and writing our code, how they really work and what all of the different functionalities that it offers. So the final two core concepts that we're going to cover today are the server RPC and the client RPC concepts. But before we get too deep into those particular concepts, it's important for us to understand what an RPC is, as we'll be using it quite a bit in our multiplayer game project. An RPC, or a remote procedure call, is when one party executes some type of functionality on another party on a shared network. So let's cover a really quick example. So imagine there are two computers, computer A and computer B. Computer A and computer B are both housed on the same network and can communicate with each other freely with no problem. A perfect example of an RPC would be if one day computer A sent some type of communication or message to computer B and asked computer B to execute some type of functionality on itself. A quick example of what that might look like in a multiplayer game is if player A performed some type of special attack on player B and player B needed to execute some type of special animation. Player A might communicate a message to player B saying, hey, I've hit you with the special attack. It's time for you to do a particular hit animation showing that I hit you appropriately. RPCs are an incredibly important concept in ML API, and as we create our game, we'll be using quite a bit. But even in the future, as you create your own game, you will be using RPCs to communicate between player, client, and server quite a bit. So it's a concept that you should spend some time getting used to and getting to know better. So as I mentioned earlier, ML API uses two RPCs, a server RPC and a client RPC. The two concepts are pretty similar, but to make things a little bit easier, I'm going to separate them out so that we know the difference between the two. Quoting Unity directly, a server RPC can be invoked by the client to be executed on a server. Basically what this means is that any particular client at any particular time using a server RPC can make a server execute some type of functionality on their behalf. The cool thing about this is that even though our server acts as the authority in our ML API framework, this allows our client to at times execute particular commands or particular functionalities that are needed that really can only be performed on the server. So now let's talk about the client RPC. As you may have guessed, the client RPC is essentially the opposite of the server RPC. Quoting Unity directly again, a client RPC can be invoked by the server to be executed on the client. Essentially, this gives power to our server to execute functionality or code directly on our client, similar to how the client could do the same to the server. In the case of the client RPC, this could be a functionality that is executed on one client or all clients, but the key thing to note is that this particular functionality would not be executed on the server. At the moment, the functionality for RPCs may not be a little bit clear, but as I've mentioned with many other things, as we go throughout the series and develop our game, we'll learn a lot more about how they work and why they are so important. So that's it for today's video. I know we covered quite a bit in this particular video on ML API and all of its core concepts, but it's really important, especially as we get deep into the code, that we have a basic understanding of these concepts, as they will be the key to us making our multiplayer game. As we continue on our game development journey, please don't hesitate to come back to this video and revisit these concepts, because as we do more coding, as we do more game development, they'll become more and more clear, and something that you might not have caught earlier, you might catch a little bit later. In our next video in this series, we're going to get started creating our Unity ML API multiplayer game. We're going to spend time building our base Unity game project, getting all of the different fundamental things that we need in place, and get ready to start building our multiplayer game. What we cover in the next episode will be great for this series as we build this multiplayer game, but also for any time that you decide to make a multiplayer game on your own or with your friends. As always, thank you so much for checking out this video and checking out my channel. It means the absolute world to me, and I'm so happy to have you here and joining me on this journey. If you did enjoy today's video, please don't forget to like the video. And if you're interested in more content like this, continuing these series and my mini series to come, please subscribe to the channel. And if you ever have any questions, concerns, comments, or suggestions, please leave them in the comments below on this video. And also, please do not hesitate to reach out to me at my Twitter, which is @BradstonDev. I'm always willing to communicate, always willing to talk. You can always send me a direct message. I love helping anybody on their journey, so please don't hesitate to reach out to me. As always, thank you, and until next time, peace.